Let's consider now one consequence of strong duality, which is complementary slackness. So let's suppose that we have a primal dual optimal pair. So we have a point x star, which is optimal for the primal problem, and a vector lambda star by star, which is optimal for the dual problem, and we have strong duality. Now, we are not deriving in this case a strong duality from some other conditions. We are just assuming that strong duality holds and is attained. Okay, if we combine those assumptions together, well, we have that f of x star is equal to L of lambda bar pi bar, because this is what we're assuming. There is no duality gap. The small l of lambda star pi star, by definition, is the infimum over x of this expression. Okay, and we don't know what the optimum is, but for sure this infimum is less or equal than this same expression evaluated at some particular point. And as a specific point, we pick exactly x star. So this is less or equal to f of x star plus this thing okay. And now, because x star is an optimal solution, and thus in particular it is also feasible, we have that this is equal to 0, this is less or equal to 0, so overall this thing is less or equal than f of x star. But this is a chain of inequalities such that the first and the last term are the same, which means that all inequalities have to hold as equalities. Which means if we combine the last two, for example, that this term here cannot really be negative, but it has to be exactly 0. And given that the lambdas are greater or equal to 0 and gi of x star is less or equal to 0, this actually means that this equality has to hold term by term, which means that this is equal to 0 for all I between 1 and m. And this is what we call complementary slackness. This is something that we saw in linear programming as well, and under these assumptions it holds also in the general case.